Welcome back, everybody, to your second monthly Tech Talk this month. You get the bonus one from Sage on Tuesday. And if you did manage to miss that one, it should be showing up on the Ceph Tech Talks page as a link, as well as the Ceph Tech Talks YouTube channel under the Ceph account within the next few minutes here. So definitely check that one out if you missed it. But today, we're here to listen to Len Scrimmer from OpenATTIC talk about the integration between Ceph and OpenATTIC. So let's take it away.
All right. Yes, thank you very much. Let me enable the screen sharing here. And hopefully this works. And you should now see my first slide. Let me know.
We're back to just seeing the web browser. There it is. Okay, now you got it.
Okay, cool. Great. So thank you very much, Patrick, for having me and for the invitation to share a bit about the work that we're doing here. I'm Lenz. I've joined the company behind OpenATTIC, which is called IT Novum, about almost exactly a year ago. I started in July last year. I've been in the Linux and open source space for quite some time. I first started dabbling with Linux during my studies in computer science in '95, I think. I worked at SUSE for 4 years back in the last century. I spent quite some time with MySQL, started there as an engineer, later turned into becoming their community relations manager. Stuck with them through the acquisition by Sun Microsystems and also Oracle. Have been doing basically the same job, just with 3 different companies. I work from home in Hamburg, Germany, so it's 7 p.m. at the moment. Beautiful weather out there. This is actually the second time today that I'm giving a talk on this subject. I just returned from the OpenSUSE conference in Nuremberg, where they invited me to give a talk about OpenATTIC as well. The subject is Ceph and storage management with OpenATTIC. I'm going to cover the general storage management part a bit more briefly, and then dive into the work that we're doing with Ceph management. Okay, so let's get going. Let's start with the vision and maybe also giving you a bit of a context where we're coming from. OpenATTIC has been around for about 5 years by now. It started its life as so many open source projects as an internal tool that was created to scratch a particular itch. In this case, it was triggered by the prices that were asked by traditional storage vendors for, storage arrays. So if you ask a NetApp or an EMC to give you a quote for a storage system, they charge quite significant amounts of money. And interestingly, it also scales with the amount of data you want to store. In today's world where your data is growing at such a rapid pace, the prices were quite ridiculous. IT Novum, the company, is a spin-off of a more traditional factory-oriented company, and they were running their IT infrastructure, and they are still doing that, but they have also started outsourcing and doing consulting and various projects. And one of them nowadays is OpenATTIC, which is being marketed as a storage management product. So they started creating a tool based on the fact that, if you take a look at a Linux distribution, it always was quite capable to fulfill storage requirements and serve various purposes right out of the box. So if you take a Linux distribution nowadays, it gives you everything you need to set up a very sophisticated storage system, be it using Samba for CIFS or NFS through the Linux kernel itself. You have various file systems you can choose from. You have iSCSI, Fiber Channel, all these things are already packaged, included, and could be used to create a storage management system. However, the big challenge really comes when it gets around to finding people that are actually capable of managing all these various components and setting up these services in a scalable and secure fashion. And also automate things so that creating new storage or new shares is easy and can be done by basically everybody in the sysadmin team and not just one guy. So what you usually end up with is either people writing their own shell scripts, they use other tools. Of course, OpenATTIC is not alone in this space. There are several other options to choose from. But I'd like to highlight a few things that maybe make us a bit unique among the other tools that you might be aware of. So the focus of OpenATTIC really is or came from the area of traditional storage. So NAS, SUN, if you want to have a server with lots of locally attached disk drives and you just want to create Ceph shares for your Windows clients or NFS shares, or even share block devices for VMware or something like that, where iSCSI is pretty popular. These are the use cases that OpenATTIC covered or started covering very early on and still does, of course. OpenATTIC by itself is also capable of managing multiple nodes in this kind of configuration. So if your single server can't host enough disks, you simply put aside a second server, stick more disks to it, and OpenATTIC will take care of them with the single management framework. So you don't have to install OpenATTIC twice. But the users or the growth of data that we've seen also showed us that the approach of how we manage storage and how OpenATTIC worked simply can't keep up and doesn't scale with the requirements when it comes to data nowadays. So we looked around and at the beginning of last year, we realized that Ceph is likely a strong contender in this space. And since it's based on open source, or it is open source, it was a natural fit. We've been watching Ceph for quite some time. We also looked at things like Gluster, for example, if that would be a suitable match. But for the sake of simplicity and then not to broaden the scope too much, we basically settled down on using Ceph as the answer for customers that exceed the boundaries of a single system and need more storage space. So yeah, that's what we started. OpenATTIC itself is open source software. Some more details, what has changed there recently, will come in the following slide. And we as IT Novum are looking into monetizing their software by providing the usual suspects like support, consulting, and services, and so on. Yeah. Since a year ago, quite a lot of things have actually changed when it comes to OpenATTIC. We are currently working on version 2 of the software, which also started sometime last year. And along with the major version number bump, there's quite a lot of change taking place. And one of the significant ones for us as a business is that we basically decided to get rid of the previous split that we had. We had an enterprise and a community edition, where the enterprise edition had a few additional proprietary bits on top, required a commercial license, while the community edition was available under the GPL but had limitations. If you wanted to contribute to OpenATTIC, you basically were required to sign a CLA first in order to allow us to actually make this dual licensing happening. We got rid of all of that. OpenATTIC is now fully under the GPL. All the components that used to be separate or proprietary have been merged into one product. It's just OpenATTIC without any distinction between different editions. And the business, of course, changes as well. So now the focus is really just on providing the services and these kind of things around the software, and not just plain selling software licenses as it used to be the case. Along these lines, we also try to be a good citizen and not just create a piece of software that happens to be under an open source license, but we are looking into generating and creating a community of users around it that is not just a community of users, but becomes a community of contributors. So the essential infrastructure parts that you need to have here, for example, is a public bug tracker. We basically opened up the Jira instance that we've had, cleaned it up, rearranged a lot of things, made it visible to the outside. So you're now able to submit bug reports. You can comment on existing issues, give us feedback in any way. We also changed the way how the development process takes place. Before, most of the development took place in-house, and the only result that you ever saw was a new release coming out every once in a while. We've now switched to a monthly release schedule. The development takes place in the open with the traditional processes like pull requests, public code reviews with approvals. We also make use of different branches. We now have what we call the release or default branch, which is supposed to be always in a stable state where all tests pass, and we could basically at any point in time cut a release and submit it by being pretty confident that it has no regressions or serious issues. Most of the development takes place in the development branch. So if a new developer works on a new feature, the development branch is the one that he uses for his own development branch and fork to work on stuff. And we have set up a Jenkins instance that performs automated tests on the code base, and only if all of these tests pass, a merge from development into the release branch takes place. We also merged the code base. Previously, things like the web user interface, documentation, tests, the enterprise edition bits, all of these were splattered across multiple Mercurial repositories. This has all been consolidated into a single repo. So now you could basically create a new feature, including the corresponding tests plus updates to the documentation within a single commit. So you can make sure that all parts and all components are always in sync and are synchronized with each other. So quite a lot of internal changes, process changes that have taken place. But then, of course, also on the product side itself, version 2 shows a few new things that we've worked on. So let me skip to that. Oh yeah, maybe just talk a little bit about where we think we differ from other projects that are around in this area. And one of the things that we try to stick with is that our focus really is on managing data center storage. So the protocols I've just mentioned before, NFS, Ceph, iSCSI fiber channel, you won't likely see us managing containers or installing an instance of OwnCloud or running a BitTorrent server in the background and things like that. There are other projects which are more suitable for these kind of tasks. We want to keep the focus on managing storage, but doing this job proper and in the right way. The choice of the GPL means you really have no real restrictions on how you use the code and what you do with it. In fact, we really want to encourage others to take a look at it and use it maybe for storage appliances and do their own branding if they like to. We are quite liberal in giving the code away and making sure that it grows in adoption. So no arbitrary restrictions in functionality, especially when it comes to the size or the amount of storage that you can manage. We couldn't care less how much disks you have in your system. It's based on plain Linux and the tools that come with the operating system. What OpenATTIC basically does is it becomes an orchestrator that uses the existing tools and just makes sure that they're being called in the right way and that the services are started and things are monitored properly. So we take a very close look at the automation of things and make sure that you as an administrator can achieve results quickly without having to go through too many hoops or even having to learn about command line utilities. Also maybe unique to us, even though it gives us a lot of pain, is that we support multiple Linux distributions. We started with Debian Ubuntu. This is where our roots are. Since last year, we've added support, adding RHEL 7, including derivatives like CentOS, Scientific Linux, and so on. Also, at the end of last year, we added support for SUSE Linux. Now that we had made the switch to RPM, this was fortunately a bit easier than the initial port. So we think we've pretty much covered the most prominent distributions that you would find in a data center nowadays. And that, of course, gives us a very well-established technology stack and also a very well-rounded and tested solution, especially when it comes to hardware support. We can safely rely on the vendor and asking the customer to take a look at their preferred Linux vendor's hardware certification list if they want to make sure that the server that they want to set up is properly supported and runs. OpenATTIC runs completely in user space, so we can pretty much stand on the shoulders of giants here and make sure that the underlying infrastructure is taken care of by people who have more clue about that than we do. And of course, using Linux in comparison to other storage management systems means that you can tap into a much larger user base. As you probably know, there are storage management systems that are based on FreeBSD or some based on derivatives of Solaris, which are technically, of course, very nice operating systems, providing lots of features and functionality. But it becomes a bit more difficult to find administrators and developers that are familiar with these platforms. So for us, Linux simply makes sure that we have broad support and can tap into a large user base. Okay, next slide. So here's a quick feature overview of what we can and kind of what components we consist of. So OpenATTIC basically has two major components, which is the whole backend thing, and then we have the web front end sitting on top of that. And with version 2, we completely rewrote the web user interface. The old one used in version 1.x was based on Next.js. And if you've taken a look at maybe at our YouTube channel or have found screenshots when Googling for OpenATTIC, you will still find lots of artifacts that show the old user interface where you have a tree-like structure on the left. Well, it was quite sophisticated and very feature-rich, but it also was quite overwhelming. So for a new administrator trying to quickly fulfill a task, he still needed to know the sequence and the order in which he had to perform steps to achieve his goal. For example, let's take an example. You wanted to create a network share on Samba. You would first have to create a logical volume, then add a file system on top of it, then make sure that it's controlled by Samba, and all these things are much more streamlined nowadays, that you can perform these operations with basically just a few mouse clicks. And the new web UI helps and guides you through the process and assumes safe defaults that you can simply take. Also, a drastic change for version 2 is that we've added a RESTful API. Version 1.x used XML RPC instead. We hope that the RESTful API makes it a bit more approachable for developers that want to automate their processes. And the web UI uses the RESTful interface exclusively. So everything that can be done through the web UI could also be performed using, well, curl or a generic Python or shell script, basically. Unified storage means that, well, we support both block-based and file-based protocols. And we also support quite a wide range of file systems. So depending on the workload and the desired use case, you can choose between the classical file systems like XFS or XT3 or 4. But we also have support for ZFS and ButterFS, which then gives us nice things like snapshots, for example, and subvolumes and things like that. On the lower levels, we basically use LVM to manage larger groups of disks. Also built in by default is synchronous mirroring of devices using DRBD. So the goal is that you can create a volume or a share and simply add a check mark or maybe select a host as a target, and we will set up the RBD in the background so the volume is being synchronously replicated to a second machine for availability purposes, for example. As I said, we have multi-node support built in. So OpenATTIC is aware if other nodes need to be managed. In that case, they basically share the database that is being used in the background to keep track of all the objects that we've managed, which is a PostgreSQL database. So it's pretty easy to set it up in a way that it can be connected from by other machines. Also very important is that we just don't manage the storage, but we also monitor it. We set up a dedicated Nagios or Isinga instance. The Isinga support was added by SUSE, by the way, just recently. And for every volume that you create, it will also be monitored by default. So we create the respective check scripts and the services and make sure that Nagios takes care of managing or of monitoring that device as well. And of course, now getting away from traditional storage and the whole part about Ceph management and monitoring, which is underway. yeah, that is currently our key focus of development. We spend quite a lot of time, especially since the beginning of this year, on making sure that the Ceph support is getting better and increasing. We started the development sometime last year, and the initial steps were creating a crush map editor and mapping RBDs. And then there was some longer period of time where we were not really making much progress, but that has changed, in particular because since the beginning of this year, we have a collaboration with SUSE. SUSE is also very active in the Ceph environment, and with SUSE Enterprise Storage, they do have their own Ceph distribution, and they are looking into using OpenATTIC as a potential management front end for this product. So they have dedicated developers now working with us, adding more features, giving us good feedback and guidance on what we should focus on first. And so far, this has really helped us to pave along the way. Right now, the majority of the developers are employed by IT Novum, so we're making quite a significant investment here. But of course, the intention is that we will manage to kind of build a community of users around it that will at some point not only just maybe report bugs, but start looking into the code and start contributing smaller improvements and feedback and things like that. But admittedly, we are still in the very early stages here. So maybe, I don't know if that's an advantage or disadvantage, but the way we want to approach is that we start with the infrastructure and framework first. And once we have a basic implementation, we start with an initial prototype of how the UI could look like when it comes to displaying Ceph information. And once that's out, we solicit feedback and want to get guidance or input if that's useful, or if we should revisit the UI design or make changes accordingly to make it more suitable for the task at hand. Getting a bit more deeply into the technical components that OpenATTIC consists of, the backend itself is written in Python. We use the Django application server and using the Django REST framework on top to provide the API. Django doesn't do any serving of web pages. The web UI is a separate piece of JavaScript, which is written in AngularJS using the Bootstrap framework. So we use Django models to basically define the various storage objects and their relations to each other. And then at some point, we need to kind of make sure that the changes that we want to make actually take place. And we have a separate process which is called OpenATTIC systemd that runs with root privileges and that gets the information from Django and knows and the instructions of what task it needs to perform, be it writing out a configuration file or creating a file system or starting or stopping a service, things like that. As I said, Nagios or Isinga are used in the backend for monitoring, and we use the PNP for Nagios extension to write graphs and store performance data in RRD files. So you can both monitor and define thresholds that where you can receive notifications. And we also use PNP for Nagios to create nice looking graphs that you can take a look at. So the web front end, AngularJS, uses the REST API, completely fresh design. You won't probably, they look very different, or the new UI looks pretty much different to the old one. It's very elegant and makes use of a lot of JavaScript trickery here. Also worth mentioning when it comes to components is that OpenATTIC is very well tested. At least that's what we're aiming for. We have a strong focus on adding tests and making sure that OpenATTIC can be tested in a fully automated fashion. So on the low end, we add Python unit tests that test individual Python modules. We have a dedicated test suite that we've developed by ourselves named Gatling that performs REST API tests. So these things can be automated quite easily, but we also have a a test suite based on Protractor that tests the web UI itself. So we basically automate a web browser to click on elements and make sure that the UI returns the expected results. All of this is controlled by Jenkins in our environment and is one of the criteria that have to pass before code will be merged. And of course, a developer working on a new feature is also encouraged and required to add test cases to make sure that we have coverage for the new functionality. Here's a visual presentation of the architecture. Starting from the top, you have the web UI or any other client application that is capable of speaking REST through HTTP, be it a Python script, curl, whatever you want. Then you have the Django application with the Django models. The information about these models is persisted in the Postgres database. And here on the right, you can also see how we are communicating with the Ceph cluster. I'm going to elaborate on that in a coming slide, but in a nutshell, we've chosen to use librados and librd and their Python bindings for the initial steps. Then we have the dreaded OA systemd, dreaded because of the confusing name, because it has nothing to do with Leonard Pettering's systemd. This process runs with root privileges and receives commands from the Django application via dbus. And then on the other hand, it basically issues shell commands. So it's capable of running commands with parameters. For certain functionality, for example, when it comes to iSCSI fiber channel, we make use of LIO and their Python bindings. So there's a dedicated Python library that we use here. So we don't have to issue shell commands and have to parse output. That makes life a bit easier. But it always depends on the purpose at hand. Right now, many of the automation is done in systemd by simply calling shell commands. And of course, they are also tracked in a log file. So you can, if something goes wrong, you can take a look at the command log and see if there was an error from any of the tools or scripts that we run. Okay, let's come to the key part of this presentation. Now that we've covered the basics and where we come from, Ceph management. So as I said, we came to the conclusion that Ceph is the answer for users of OpenATTIC that are looking for solutions to scale data across more than just a single machine and are anticipating rapid data growth that simply can't be kept up with single disk servers. So one thing that we've realized pretty early on is that, well, on the one hand, Ceph does a lot of things by itself and is pretty autonomous. But then again, it also requires lots of hand-holding. And well, right now, most of these things need to be done on the command line using the built-in command line utilities. And it provides quite a high level of complexity. So from a management perspective, I think Ceph still has lots of room for improvement to better integrate into operations and getting a bit more sysadmin friendly, so to say. There are, of course, a number of tools because we're not the only one realizing that, and others scratched that itch much earlier. The de facto tool probably here is Calamari, since it was developed by the Ceph folks themselves. Intel started creating the Intel Virtual Storage Manager VSM a few years ago already, and that one is pretty full-featured and quite impressive. Other people have looked into more of the operation monitoring point of view. Ceph Dash is a nice candidate here, and that gives you a web-based dashboard displaying the key performance parameters of the entire cluster. So some of them are limited in functionality. Others, again, you don't really know where they're heading, or they have been abandoned, or there's just a single developer doing that in his spare time. So none of these really fit the bill or were an acceptable starting point for us, especially since we wanted to have both the Ceph management part, but it also should have or needed to integrate with the traditional storage management part that OpenATTIC provides. So we took some time in market research and trying to figure out what the best approach for us would be. And what options actually exist if you want to become a Ceph management tool. So the goals that we've defined is that we want to not only create a monitoring GUI tool, so not yet another dashboard, but also a tool that allows you to actively manage the Ceph cluster in such a way that you as an administrator really want to use it and it's not getting in your way. That is really one of the key design goals that we want to get into, that the functionality should help you to get your job done. Also that we scale without becoming overwhelming. I mean, when you're looking at Ceph clusters, they can quickly become quite sizable when it comes to the amount of objects, like OSDs, like the number of servers that you have. How to visualize and provide that information without inundating the administrator or confusing him is also something that we want to make sure that OpenATTIC is a good fit here. And that is quite a challenge, because on the one hand, you want to shield the administrator from most of the unnecessary information, but on the other hand, in case something goes wrong and he needs to be made aware of, he should be able to quickly drill down and figure out what's actually going wrong and how it can be resolved. So especially this area will require some significant more amount of work. We are still in the early stages here. Also, a key point for us, you should still be able to run your Ceph command line tools without OpenATTIC getting confused. That basically summarizes it. So if you start, or if we would have started using OpenATTIC and Django as is, the first approach that we were thinking of were simply modeling the entire Ceph cluster as Django models in the database and persisting all the information in Postgres. But considering the amount of churn and how quickly the Ceph cluster by itself changes its face, so to say, and we realized that it will become quite tricky to keep the data in the database consistent with the reality. And so we needed to first come up with a way of how to use Django with our existing infrastructure and still manage a dynamic thing like a Ceph cluster, where in comparison to what we did before, there is no OpenATTIC instance running on each of the Ceph nodes. That also is something that we don't want to do. You're not required and should not be required to install OpenATTIC on each machine that is part of your Ceph cluster. That's simply not possible. Okay, further research when it comes to the implementation revealed that, well, the first question is, okay, how do you manage a Ceph cluster? What API can you use? So we started looking at Calamari, especially the Calamari server part that was later spun off. And if you look at the architecture of how Calamari is built, you will realize that it's pretty similar to how OpenATTIC looks like. It's also a Django application. It uses a separate process in the background to perform tasks. So choosing Calamari sounded interesting because it would allow us to simply use a RESTful API to get jobs done. But it would also add quite a lot of additional overhead, because we would basically have to run 2 Django instances. The REST API also meant that for availability purposes, you would be able to kind of set up maybe 2 Calamari server instances, and then you need to figure out how, on which of these nodes is the REST API currently located. You would need to have a load balancer. So it somehow sounded to us that this is way too much work and overhead, and so we dropped the idea pretty later on. And of course, well, it's a distributed system. What kind of tools are available to manage? Maybe getting back to the management API first. As I mentioned before, we now settled down on using librados and librd for the time being. This gets us quite far for the initial steps that we have in mind. We've defined several kind of stages in which we want to tackle the whole Ceph management tasks. And with librados and librd, we also get quite far. And once we have reached or have accomplished everything that we want to implement there, the next step is, of course, okay, how do you work with the remote nodes? What can you do to make changes on a remote system? And of course, there again are quite a number of tools available that you can choose here. You could either use plain SSH and run shell commands there. And then, of course, you have a wide choice of deployment tools, Salt, Puppet, Ansible. We basically decided to go with Salt, in particular because this is something that SUSE uses, and they have the expertise and give us guidance and assistance here. But we still want to maintain other options if possible. But for now, the initial implementation will be done using Salt. So anything that requires remote execution on any of the Ceph nodes will be performed using Salt Stack. Also, we want to not only manage or monitor the entire cluster's health, but we also want to monitor how the individual nodes are doing. If there's a problem, if there's a memory shortage, or if the network bandwidth is being exceeded, or if a disk is failing, things like that, you need to have local monitoring running on each of these nodes to capture this information and collect it. And right now, we are using Nagios on the OpenATTIC instance, but we think of Nagios of a bit of a too complex and heavy solution to be running on all the nodes. So collectd is likely the tool that we will be using here. At least that's the direction of research that we're currently looking into. And of course, that whole thing needs to be scalable. So especially with monitoring and capturing performance data, you need to make sure that you're not saturating any node or creating any kind of bottlenecks here with the amount of data that's being generated. So there are still a few interesting challenges to tackle here. Our first step when it comes to monitoring is really just monitoring the Ceph cluster with what you can obtain through LibRados and Ceph Health, basically. So similar to what Ceph Dash is doing, we took quite a lot of inspiration from what he is doing there. That work is currently in progress, and we hope to have an initial draft of the dashboard. Well, maybe by sometime next week. We have a project going on, or an event where we will be focusing on Ceph development. I'm going to talk about that in a later slide. Oh yes, so one of the things or challenges that I just mentioned is that for consistency reasons, we decided not to persist data in the local Postgres database, but we still wanted to maintain the possibility of using all the nice things that Django gives us with Django models. So what we came up with, we dubbed it NoDB models. They look and feel like Django models, but the way they obtain information and how they store it is they use an arbitrary API. In our case, we use LibRados, for example. So we have models for pools, and we simply query the cluster for a list of pools and use LibRados calls to obtain that information. And the other way around as well, if you want to create a new object, again, we'll be using the Rados calls. So in that way, and we can make sure that the Ceph cluster, or that the information that is included in the Django models always reflects reality and is not out of date. Okay, this is kind of a high-level overview where we currently are with the development. So this whole Django NoDB backend architecture and framework is in place since a few months ago. That took us some time to get right, but now we have a foundation that allowed us to quickly build on top of it. And the OpenATTIC REST API now provides quite a wide range of Rados calls that you can perform. We took the Calamari REST API kind of as an not really as a template, but you can see it has been inspired by what Calamari is doing with their REST API. You can map RBDs, and OpenATTIC then treats them as regular block devices, so you can share them with iSCSI. You can create file systems on top of them. We can list pools, OSDs, and RBDs and their various details. So we have table views for these. And the next step, of course, is not only being able to view all these elements, but make changes to them, edit details, create new ones, or delete existing ones. So these are the next steps now that we've kind of the basic infrastructure in place. And cluster health and performance monitoring and creating a dashboard. So we've now extended the Nagios support that we have in our backend already. So OpenATTIC is capable of, well, creating arbitrary Nagios configurations for things like disks or volumes and things like that. And we've now extended it to create the monitoring configuration for the Ceph cluster itself. So Ceph health will be tracked. And we also create RRD files to keep track of long-term information. So you can take a look back and see the history of how your cluster has been doing a longer time ago. So far, OpenATTIC then used RRDs to generate PNG images using RRD tool, and then just displayed the static PNGs embedded in the web page related to the information that it wants to display. With the upcoming Ceph dashboard, we are taking a slightly different approach since, well, let's face it, RRD tool PNGs look kind of, they came from last century. They have been around for quite some time. They display all the information you need, but we wanted to make it a bit more interactive and a bit more modern in a way. So we have extended the OpenATTIC backend so that it not only just returns PNG images, but can also return the RRD data in the form of a JSON object, which then allows the web UI to use JavaScript to render the information in the web browser directly. So you get a much more interactive display of these graphs, and you can dynamically zoom in and out, and you simply get much more flexibility with using JavaScript in the browser to work with this data. And one of the things that we've added early on is support for managing more than just one Ceph cluster. So in most users and customers likely just have one, but in the case you have an environment, there's maybe a test or a development in the production setup, it might come in handy that you are able to use the same tool for looking and managing both of them. So that's also one of the things that we try to keep in mind while working on all the other features, that it should also always be possible to manage more than one cluster with this tool. This is just a quick overview of the current state of our REST API. You can see all the various endpoints that we've created and what methods they support. As you see, there are still a lot of blanks, so we are by no means fully done with that yet. But for each of these squares, basically, you will find a Jira issue in our tracker that explains what we are trying to accomplish with a description of what the outcome should look like. If there's time, I also have a web page on our public wiki that basically summarizes all the issues and gives kind of a roadmap and kind of a flow. So this is what we are currently working on or have in our near-term plans. So next thing that will be the most visible change for likely is the dashboard that we're working on right now, including performance graphs. So one of the design decisions that we've made here is that compared to some other dashboards, we don't want to basically show full live data. So some of the dashboards basically start, once you open the web page, they start querying the Ceph cluster, and then you see a graph slowly building up. Instead, we will be using the RRD, the data stored in the RRD file locally and start displaying that. So usually if you want to look at a dashboard, you want to see also the historical context of how your cluster has been doing half an hour ago or so. But then, of course, as soon as the RRD is being updated, we will also refresh the screen. But it's probably not something that refreshes every second or every 5 seconds. The question is if you really need that near-time health information anyway, because you would rather want to take a look at trends and historical information to make sure that your cluster is in a healthy state. Of course, the entire part about OSD monitoring, management, pool management, right now, we basically just create a list of objects and their properties. And the next steps, of course, will be that you can just look at these objects, but you can start making modifications to them. For example, by clicking at one of the objects and then making changes to that. So these are really pretty high-level terms which break down to quite a number of individual action items and tasks, and they have all been broken down in the Jira. And if you want to take a closer look, I'm not going into the nitty-gritty details here. Especially the part about pool management has a lot of complexity involved if you're talking about erasure coded versus replicated and what have not. I admit I'm not that deeply familiar with the innards of Ceph by itself. And we are quite grateful that with SUSE, we now have a partner who does have engineers working on the Ceph cluster, and they also have customers with large real-life clusters and real-life problems as well that give us good use cases to look at. CephFS, of course, now that Joule is out, is a very interesting aspect that many users are interested in. Further down, of course, Rados gateway management, creating users, creating buckets. And then, of course, the whole thing of not just managing an existing Ceph cluster like we currently assume, but being able to start adding more nodes by ourselves and configure them. And this is where the whole thing with SaltStack comes into play. So as a prerequisite for getting started with that work, we need to have the basic Salt framework in place. So we have the models in Django that define the various entities, and we need to get started somewhere. Maybe we start with being able to start and stop services on remote hosts or something like that. That depends, but it will be something that will evolve over time. We will stick to our monthly release cycle, and we hope that with each release you will see another bit of Ceph management monitoring showing up that gives you a chance to take a look at it, give us feedback, and then we may take the next cycle to refine and hone it and make sure that it works as expected. Here's the link to the public roadmap. Since I can share my screen, I will quickly switch to a web browser to give you a glimpse on how that looks. I hope that works. It does not. Interesting. Maybe I have to stop the presentation first. Somehow I can't switch to the web browser. Let's continue with the slides. Oh, brilliant. Sorry about that. I think we were right here. So yes, the whole Ceph management roadmap is on the wiki, and we use Atlassian Confluence as the wiki, which gives us very nice features like pointing to Jira issues. And once you resolve a Jira issue, the wiki page will also automatically reflect the state of that issue. So it gives you a nice overview of what tasks are still open and which have been resolved. Even though some of these tasks are pretty large and then again consists of subtasks that might have been resolved already, but the top level issue is still open until the last remaining action item has been checked off the list. And yes, I still have to work especially on the steps further down the roadmap. So the wiki is by no means complete yet, but this is the action items that we've defined here already give us plenty of work and stuff to work on for the next month. So this roadmap also is a living document that will be extended and expanded. And also it's likely that priorities or the sequence in which we will tackle things might change depending on user feedback. So if a majority of users thinks that we should rather first look into tackling this than that, we are of course happy to make adjustments here. Yeah, that's about it. I don't want to challenge the demo gods, and especially since I can't switch to my web browser, I'm going to skip doing a live demo also in consideration of the time. I have a few screenshots for you to take a look at, and you will get a few links, including a link to a live demo that you can take a look at later on. So if you log into OpenATTIC, the first thing you see here is our storage management dashboard. This is still the quote traditional storage management side. One of the things that might be worthwhile mentioning here are the wizards that we've created, which basically guide the administrator through creating a certain type of storage. And of course, it would be an an option to create similar widgets that perform certain Ceph-related operations, maybe creating a new OSD node or setting up a new OSD process or things like that. Work that is currently in process as we speak is that the layout of the dashboard can be changed dynamically. So all of the widgets that you see here, you will be able to drag them around and resize them, and the web UI will keep your selection stored in your web browser. So next time you log in, the layout will look exactly as you've left it. And we're also thinking of maybe creating some pre-configured layouts to choose from, so you don't always have to start from scratch. Ceph pool list, that's how it currently looks like. So you can see it's a table view starting with the name of the pool, pool ID, size, utilization, placement groups, all the various aspects. And if you click on an item on the list, you get a more detailed view underneath the table here. Yeah, that's basically the initial view that we've created. And based on feedback and suggestions, we are open of maybe reducing the amount of information displayed by default or rearranging the fields, or maybe we're missing some information that you think is crucial. One of the things that I'm keen on adding here, for example, is that you are able to sort the list by various headings. So particularly probably by the amount of space used. So you can click on it and you see this the pool with the highest fill level right on top, so you can make sure that you can do something about it. This is the initial step at an OSD list here, listing the names of the OSDs, the host they are running on, and their status. This is the crush map editor that I've been talking about. On the left hand, we basically have a visualized version of the crush map, and you can use drag and drop to move these elements around to create the representation of the failure domains that you need. For example, how many data centers, how many racks, how many hosts, and how they should be, what kind of replication level you want to have between those. Right now, it's fairly easy to shoot yourself in the foot or keep the Ceph cluster sufficiently busy by making accidental changes here. That whole screen too probably needs much more polishing, but at least this is our first step at it. And if you think that is something that is useful or should require additional improvements, just let us know. The thing is, we have a certain level of knowledge about Ceph ourselves by now. We do have, of course, the people at SUSE giving us good guidance and feedback, but we are also interested in hearing more about practical use cases and people giving OpenATTIC a try and telling us about kind of the gotchas they run into, or the things that they would like to see. So at this point, we are in an early stage, which allows you to really grow with us and make sure that you leave your impact and get your requests in early. This is a screenshot of how the volume management currently looks like. And for example, here you can see from a server disk and the PNP for Nagios graphs that we're using here, using RRD tool. This is the old method of how we are displaying RRD data. These graphs are probably very familiar to you since they have been around for, several years. But as I said, the intention is that the Ceph cluster dashboard will use a more modern version, and we're using dedicated JavaScript graphing libraries for that. Oh, one of the nice things or interesting little features that we have, I like to mentioning it because I haven't actually seen it in any other web UI so far. As I said, the OpenATTIC web UI uses the REST interface exclusively to communicate with the OpenATTIC backend. And of course, if you browse the API endpoint with the web browser, it's self-documenting. You can click on the various sub-links, so to say, and you get a list of options and things like that. But if you are a developer and you want to create a small script that performs or automates a certain task, like, for example, creating a share or a storage volume or something like that, One way to do it is you enable our API recorder. Then you perform the steps that you want to get done by clicking on them in the UI. And once you're happy with the result, you click stop, and the API recorder will wrap those API calls in a small Python script that you can then cut and paste and use as a template for creating your own script. So you don't really have to look up the API calls. They're built into the script already. Oh, and next week we'll be quite busy. As I said, I've just returned from the OpenSUSE conference, which takes place in Nuremberg, Germany this week. And immediately afterwards, SUSE has scheduled what they call their Hack Week, which basically gives SUSE employees almost 2 weeks of time to start hacking on a project that they identify by themselves, and they can work on basically whatever they want. It's a bit similar to what Google used to do in the past when employees had a day in the week working on a side project. And SUSE Hack Week has been taking place, I think, at least 2 or 3 times in the past years already, maybe even more. And next week, the entire OpenATTIC team has been invited to come to Nuremberg into the SUSE offices, and we will be focusing on hacking on Ceph-specific features together with the SUSE developers. And the Hack Week is open to the public, basically. Everyone can join projects or suggestions that are listed on the project website. For example, if you would like to take a first step at an OpenATTIC feature, take a look at our OpenJira issues. Ideally, get in touch with us on Freenode or hang out on our Google group. Raise a suggestion on what you would like to work on so we can hash out a quick plan before you submit it to the Hack Week website. And then we'll be around the entire next week to basically coach and guide you. And yeah, hopefully you have some fun and you learn something, and in the end we'll come up with a piece of code that we can then integrate in the OpenATTIC code base. So that's the plan for next week. We are looking forward to that, and we are quite confident that by the end of the week we will have a few more nice things to show off with regards to Ceph monitoring and management. Here is the usual link dump. OpenATTIC.org is basically the website you need to follow. All the links from there are listed there as well. The live demo is on demo.openattic.org. It is refreshed on the top of the hour, so don't be confused if you're working on it and all of a sudden your instance is being restarted and looks pretty new again. Docs is maybe something worthwhile mentioning. We use restructured text and Sphinx, so the usual way of how documentation is done in the Python world. So even if you can't code, our manual definitely can is in need of some further extension and improvement. Pull requests for that are always very appreciated. Reporting bugs on Bitbucket. So quite contrary to most other open source projects, we are not using Git and use GitHub. We are a Mercurial shop, and we're hosted on Bitbucket. But if you're familiar with Git and the concepts behind it, Mercurial shouldn't be a big hurdle for you. Yep, we tweet, we're on Google+. And with that, I think I can leave it open for questions if you have. I don't know if that's actually possible, Patrick, but if there are any questions, I'm going to stop my screen sharing now.
All right, if we have any questions for Lens, you can go ahead and you put them in the chat or put them above. Otherwise, I think we're good.
So there's the chat, okay?
There's a question.
Okay,
right
the
there.
question is, are there any tools to help a user of a larger system to identify a bad disk in an RBD or other failed hardware? Not yet, but yes, of course, this is one of the key use cases. And I think the whole point about especially OSD management is something where a Ceph administrator spends most of his time because, well, we are dealing with hardware here, so that's where most of the failures usually come from. So yes, that is something that we will implement at some point, but it's not there yet. But it's high on the list of things that need to get done. So as I said, we want to focus on the practical things first. So it's also helpful guidance for us. If you're running a Ceph cluster, what are the usual things that you run into, and where would you expect more help from a tool like OpenATTIC? So if you have ideas, suggestions, or if you think we are missing something on the roadmap, please let us know. Any other questions? Doesn't seem to be the case.
All right. Well, thank you very much, Lens. I appreciate it.
Thank you very much for hosting me. I hope it was worthwhile. And have a good day, good night, wherever you are. Thank you.